Hello everybody, welcome to a review in algebra. On this video, we will talk about exponential decay. And in particular, we will do one example in a problem with half-life. This is a review video, so we will not go over too much detail with the problem. So the problem, first thing we have is the half-life of certain substance is 50 years. And then after that, question, how long does it take for it to decay to 75% of the original amount? So as you see here, this diagram, we should they have two parts. So the first part, we have the half-life in 50 years. So the half-life meaning that the amount will decay to half of the original amount. I'm sorry, will be half of it. And that's what we have. So we want to substitute that into the equation. We know that the half-life is 50 years. So that's going to be our T. And T, 50 years. We have everything except for the rate, K. We're going to solve for K here. To do that, first, both sides have A naught. We divide that on both sides, or let's just cancel out. We will have 0.5 times 0.5 equal to E to the K times 50. Now we just need to solve for K. K is on the exponent. To solve for K, we need to take ln on both sides. So I will take ln on both sides. And we write this as 50K. Now we take advantage of the properties of a log. We can take the exponent outside as a coefficient. So this will go outside. So we will have ln of E. And ln of E, this can cancel out. We actually can cancel from this step, but sometimes it's easier to see it like this. So we have ln of 0.5 is equal to 50K. So for K, we divide both sides by 50. So we have ln of 0.5 divided by 50. If we do that, we have negative 0.0138639. We can just give the ln of 0.5 divided by 50, but that is negative. By the way, it makes perfect sense if the rate is negative, because this is an exponential decay problem. The rate should be negative. That's the first part of the problem. Now we're on to the second part of the problem. How long will it take for that sample to go to 75% of the original amount? Now we have 75% of the original amount, meaning that A is equal to 75% of the original amount. And then we substitute into the equation. Now that we know the rate. So when we substitute, we have 0.75 A naught, and that equation. So it doesn't matter what we have initially, it will cancel on both sides. We know the rate now is negative 0.01386 and t we don't know because the question does ask us for how long. So we do need to find the time. Right, and the solution of this kind of like what we did over there. First, both of them have a naught on both sides, divide by a naught on both sides. Just cancel out. And now, again, we solve for a variable on the exponent. To do that, we check ln on both sides. And we can take the exponent outside as a coefficient, or like I mentioned before, ln and e just cancel out. And to solve for t, we will take ln of 0.75 divided by the rate. And if we do that, we should have about 20.75 years. Or approximation. Or we just take ln of 0.75 divided by this exact values here. Right, so that is the problem. I hope you find this video helpful. Thanks for watching.